All right, on page 779 today, we're going to be finding the area of parallelograms today. And if you remember, a parallelogram has four parallel sides, or two pairs of parallel sides. So we basically, unless the shape is rotated, then the top is parallel to the bottom, and the left side is parallel to the right side. And the area is equal to the base times the height. All right, now, in this case, we're going to call the top the base and the bottom the base. All right, you're only going to use one of those dimensions. But what you have to be real careful of when you're finding the area of parallelograms, and when we get into tomorrow's lesson, that this dimension right here is the height. And in all of geometry, it's super important that you always use a base and a height that are always perpendicular. Base and height are always perpendicular. The base and the height of a shape are always perpendicular to each other. So with that, we're going to do a couple of practice problems, but I want to touch on one more review. Do you see this height that we just referred to, this dashed line that's perpendicular to the base? Okay. When we drop in this height, we form a right triangle here. All right. And earlier in the year, we covered some special right triangles. And in today's assignment, in your assignment this week, in some problems, you're going to have to find the height using either the Pythagorean theorem or rules from special right triangles. So the two special right triangles that we talked about earlier this year were the 45, 45, 90. I hope you remember. All right, if you've got a right triangle and one of the acute angles is 45 degrees, then the other acute angle is 45 degrees. And this special right triangle has rules. And the rules were that if one of the legs is equal to x, then the other leg is equal to x. All right? In a triangle, if you got two congruent angles, then the sides opposite those angles are also congruent. And then the length of the hypotenuse is equal to the square root of 2 times one of the sides. Okay? So square root of 2 times one of the sides is the length of the hypotenuse in a 45-45 right triangle. The other type of special right triangle we worked with was a 30-60-90. And in a 30-60-90, we've got a 30-degree angle, we've got a 60-degree angle. And if you remember that the side opposite the 30-degree angle is the shorter leg, all right? The side opposite the 30-degree angle is the shorter leg. The side opposite the 60-degree angle is the longer leg. And if this short leg was equal to x, then the hypotenuse was twice the length of that short leg. So the hypotenuse is 2 times x. And that the long leg was equal to the square root of 3 times x. So you can use those rules in any triangle, any right triangle, where you need to find the height of these parallelograms. All right, so let's take a look at a couple of problems here. And I'm just going to actually do some of the problems from your practice today, but I'm going to change the values in these examples, so they should be set up for you pretty good. So we got this parallelogram right here. I'm basically doing number 1 on page 783, but I'm going to change the numbers. You're asked to find the perimeter and the area. You're given the top here is 15. This is a parallelogram. And we're not going to use 15. Let's use something like, let's use 19 here. You're given the left side of that shape is 13. We'll use 11. And we need the perimeter. And we need the area. Well, in a parallelogram, all right, if the top's 19, then the bottom's 19. If the left side's 19, then the right side's, or I'm sorry, if the left side is 11, then the right side is 11. All right, perimeter's equal to the sum of the sides. So we got 11 plus 19 plus 11 plus 19. And that's equal to 60. Now, to find the area of this parallelogram, this dashed line right here, that represents your height. And you're given this dimension right here is 5. So we need this height. And we're not given any angle measures, so we can't use any special right triangle rules. But we can use the Pythagorean theorem. So we need to find h here. So we're going to say that 5 squared plus h squared equals 11 squared. So subtract 5 squared from each side. And our height squared equals 11x squared minus 5x squared, 96. And then we find the square root of each side. So our height is equal to the square root of 96, which is 9.8. So if our height is 9.8 and area equals base times height, then our area is equal to 19 times 9.8. Which is 186.2. All right, and problem number 2 there, that's pretty straightforward. If you want to just look at it, you're given the base and you're given the height. All right, so if the bottom is 18, the top is 18. If the left side is 20, the right side is 20, and they give you the height. They give you the dimension of that dashed line. So that's just a multiplication problem. But let's take a look at number 3 there. And what we've got, let's call this bottom 14, and the top would be 14. And if the left side, they're calling it 20, I'm going to use 22. If the left side's 22, then the right side's 22. And we've got this dimension. And we're given a 60-degree angle. So again, your perimeter is just the sum of the sides. So the perimeter is equal to 20. You can do 2 times 22 plus 2 times 14. All right, 2 lengths plus 2 widths. That'll give you the perimeter. So 72 is a perimeter. And our area. Now in this case, our area, look at this right triangle that's formed over here. If you're given this 60-degree angle, it means that this triangle is a 30, 60, 90 right triangle. And in that triangle, okay, we need the height. Here's our height. The height is the long leg of that triangle. All right, so if I pull that triangle out of there and just kind of sketch it right here, we've got a 22, we need the height, and this angle is 60. So in a 30, 60, 90, the short leg is half of the hypotenuse. So if we take half of 22, this piece would be 11. And then if we take 11 times the square root of 3, that would be the height. So this would be 11 radical 3. So there's our height using special right triangle rules. All right? The 14 in this picture is this dimension. It's not that piece of the triangle. That piece of the triangle right there is half of the hypotenuse. So now our area is equal to the base, all right, which is 14, times 11 radical 3. So 14 times 11 times 3 square root. 266.7 is the area. All right, so let's take a look at one more where you're going to use the 45, 45, 90 right triangle rule. I'm looking at number 4, so you can draw that, and then I'm going to change the numbers a little bit. Let's do a 30 up top. Here's our height. This piece is 5. And you're told that this is 45 degrees. So now, if the top of this parallelogram is 30, then the bottom, the other base, it's also 30. So our perimeter is going to be equal to 2 times 30 plus 2 times, we need the other two sides, okay? And again, we've got a 45, 45, 90 right triangle. And in a 45, 45, 90 right triangle, the legs are the same. So this height right here is going to be equal to 5. And this hypotenuse is going to be equal to one of the legs times the square root of 2. So this piece is 5 radical 2. All right, so for the perimeter, we got 2 times 30 plus 2 times 5 radical 2. So 2 times 30, that's 60. We got 60 plus 5 times 2 square root equals 7.1. So perimeter 67.1. Our area is equal to a base times the height. 2 perpendicular segments. So 30 times 5. And 30 times 5 is 150. Questions? All right, if you have a problem finding the base and the height, bring me your paper. I'll show you how to find the base and the height, and I'll tell you whether you need to use special right triangle rules or the Pythagorean theorem to find your height or to find one of the sides of the parallelogram. So your practice for today is going to start on page 783. You can do 1 through 4. Ten, 11. And then 17 through 20 over on the next page.